So now let's start talking about operators. Specifically, we're going to start with the numeric operators. So we've already been talking about one extensively, and that's this. This is the assignment operator. So as of right now, this is the only way that values can change. So here if we said something like a plus b, right, because there's no assignment operator, neither a nor b is changing. All that's happening is we're performing this calculation where it says, okay, a, that's 10, and b, that's 20. So a plus b, 10 plus 20, that's 30, and that's what we have right here. So a and b aren't going to change. So if we run a plus b, a minus b, a times b, and a divided by b, these should be the values we get, these four. So plus, minus, multiplication, those are all pretty straightforward, but let's see what happens when we run this. So we got 30, good, okay, let's bring this window up. We got negative 10, we got 200, and then we got 0. So we got a 0 here instead of a 0.5, which is what we should have gotten. Well, why is that? Well, when we say a divided by b, we're not just dividing. What we're actually doing is called integer division. So a is an int, as stated here, and b is an int, as stated here. So when we divide a and b, our result is going to be an int. Now, 0.5 is not an int. 0.5 is a floating point number. So that means it has an integer and it has a decimal point, which, going back in here, we know it's either a float or a double. Because integers, the int, short, and long, cannot store decimal points. So then what's actually going on here? Why did we get 0? So when you divide, actually here, let's do it in this. When you divide 10 and 4, right? So 4 goes into 1 0 times, and then 4 goes into 10 2 times. 4 times 2 is 8. We brought that down, subtract, and we get 2. Now normally, we would put a decimal point, put a 0, drop this down, and then 4 goes into 20 5 times. We put that decimal point, and our result, 10 divided by 4, is 2.5. However, since we're dealing with integers, and again, integers cannot store a decimal point, as soon as we get to this decimal point step, we stop. We stop what we're doing, drop everything, and in this case, 10 divided by 4 is 2, and that's the long and short of it. So even though 2.5 rounds up to 3, Java just ignores the decimal point and calls it a day. Even if we did something like 19 divided by 10, right? 19 divided by 10 gives you 1.9. But as far as Java is concerned, that's just the number 1, because 10 times 1 is 10, subtract, we get 9, and since 9 is less than 10, we're done. So, if we go back over here, so how do we get the decimal point then? Well, either one of these numbers, a or b, has to be a float or a double. So we'll call a double. So double a equals 10.0. So now when we run this, okay, so now we get a bunch of doubles, because doubles store more information than an int does. And it's not just the fact that, going back to a couple of videos ago, double stores a 64-bit number and int stores a 32-bit. It doesn't have anything to do with that. It has to do with the fact that a double stores physically more significant data than an int does. So even if we used a float, which is a 32-bit, versus a long, which is a 64-bit, if we combine those together, so we'll call this a float, and we'll call this a long. So we're getting an error here because 10.0 is not a float, and if we put an F there, then it's fine. This is just a weird Java thing. So in order to specify that a number is a float, you need to put an F at the end of it when you're initializing like this. And then sometimes you'll have to do the same thing for a long. You'll need to put an L right there. So we'll do that anyway. Okay, so now if Java takes the variable that stores more memory, then theoretically all of these numbers that it outputs should be long type variables, meaning they should look like integers, not like decimal points like we have here. But if we run it, notice again they're all decimal points because float stores more significant data than a long does, even though a long stores more physical memory than a float does. It'll always take the float because it's more significant. It stores that more precise data because it has the decimal point. So, division, as long as one of the numbers, at least one of the numbers, is a floating point number, then the result will be a floating point number, which means we'll be doing floating point division. If both of the numbers are ints or some sort of integer, then we'll just be doing integer division. Now, this isn't all of our operators. There's a few more that we can do. We also have a mod b. So this falls in line with the division operator, specifically when we're talking about integer division. So yes, we'll be getting some errors because they're the wrong type that I'm specifying, and now everything's good. So what is mod? What is happening here? Well, modulus, if we go back to this, so 10 divided by 4 is 2 when talking about integer division. If we were to represent this in the way that you learned in like 3rd or 4th grade, 10 divided by 4 equals 2 remainder 2, right? Because there's 2 left over here. 19 divided by 10 would be 1 remainder 9, right? Because there's 9 left over down here. So when we say mod, we're not actually talking about this number. You know, we're not talking about this or this or this. We're talking about, or I'm sorry, not these numbers. This number. When we say mod, these are the numbers that we're talking about. These remainders, right? So 10 divided by 4 equals 2. 10 mod 4 happens to be 2. So we'll use this as our example. So 19 divided by 10 equals 1. 19 mod 10, right? This is where we get the 9, because 9 is our remainder. So if we go back over here, if we do a mod b, so 20 doesn't go into 10 at all. So that's where we got the a divided by b. That's actually 0, which means our remainder is going to be 10 because that's everything that's left over. So this should give us 10, and if we run it, sure enough, our remainder is 10 because that's the very last number that we printed out. So mod is very helpful for determining how much how much is left over if you have a certain amount. Obviously, if you're dividing, it's whatever your remainder is. It can also be used to determine if a number is even or odd, because if b is 2 instead of 20, if we run this again, so here, this last number, if the mod of a number, if we have a mod 2, any number mod 2, that number is even if that result is 0, and it's odd if the result is 1. So it can be very, very helpful for determining whether or not a number is even or odd if we don't know initially what that number is. Because we can go through and we can do a bunch of random calculations. A equals a plus 67, and we can say a equals a times 40, and do all that sort of stuff. and then get some sort of random number. We can run it, and we can find out, okay, based on the calculations, we got an even number for a. Now, what I just did here, this a equals a plus 67, a equals a times 40, this can be shortened to something a lot simpler. So we can say a equals a plus 67, or we can say a plus equals 67, and we can just combine those operations into one. Same as a equals a times 40, we can again combine that into a times equals 40. Now you can do this for all of these operators, plus equals, minus equals, times equals, divided by equals, and mod equals. It works for all of them. And then plus and minus also have their own specific uses. So let's say we wanted to make a go up by 1. Well, we could say a equals a plus 1, or a plus equals 1. But again, there's a faster way. Instead of a equals a plus 1, or a plus equals 1, we can say a plus plus. So that means increment. Make a go up by 1. So before I said anytime you want to change a number, you need the assignment operator, which is what this is, right? And it always goes right to left. I'm not sure if I mentioned that or not, but it always takes the number on the right and assigns it to the number on the left, or the variable on the left, I should say. So this is the only, or one of the very, very few times where you don't need the equal sign, or the assignment operator, to change the value of a variable. In this case, we're making a go up by 1, and we're not using the equal sign at all. And as I already mentioned, the minus has its own. This is called decrementing, and as you can probably guess, it makes a go down by 1. Okay. So now, what if we have, instead of putting one of these operators in front of the equal sign, what if we put an equal sign in front of an equal sign? Well, that is getting into Boolean operations, and we'll talk about that in the next video. But before we go on to that, I just want to mention a couple more things. You might also be thinking, well, if a plus plus goes up by 1, and we have all these other operations and whatnot, well, wouldn't a star star be like squaring a? And you'd think it would, but it's not actually. As you can see, we have an error. This isn't how you do squaring, or even if we did something like this, a to the power of 2, it doesn't work that way. We don't have, there's no power operator. If you wanted to raise something to the power of 2 like that, you would instead have to do the math class. So math.pow and then a, comma 2, right? So this would be taking a and raising it to the power of 2. Again, this is another example of a doesn't change when we do this. So if we wanted to change the value of a to squaring itself, then we would say a equals. And this is giving us an error because it's trying to, this gives us a double. So we'll just change that to a double for the sake of example. So now a squared, we store that back in a. And actually, here's what we'll do. We'll just say double C equals. So now we're squaring a and we're storing in C. Or alternatively, if you wanted to square a efficiently, you could say a times equals a, and that would be another way to do that. All right, so that'll do that for this video. And we'll start going into the more of the Boolean operators. So working with true and false in the next video.